So I've worked in the crypto economic space for about 4 years. I was at Block Science before I was at Pantera, and the way I typically work is based on this idea that the way you solve a strategic problem is you try to find this little toy game that sits at the heart of it. And that's kind of conventional wisdom inside economics, and I found it to be the most successful thing in terms of formalizing your goals, and especially when you're doing something big and uncertain, and the sort of thing that might be retro PGF funded later on because nobody can understand it, a way of sort of formalizing your instincts. And so in that vein, I want to talk a little bit about really simple toy game theoretic concepts that can kind of build in that direction. Now I get to cite a quotation of a famous game theorist who kind of said what I just told you in so many words. Crucial step to solving a real-life strategic problem nearly always consists in locating the toy game that lies at its heart. Particularly in this kind of Agent Cooper meme here that I have, it's answering the question, what game is this? Well, game, equilibrium, all this stuff, I'm gonna throw this around. It's gonna sound really jargony and confusing, so let's do a real simple, basic way to let you kind of feel what it is, if that would help. So let me see, can I ask you two to be my volunteers? Could you just both stand up? You and you, if you would. Yeah, please. Just stand up, that's all you have to do. All right, cool. All right, so I'm gonna consider this a public goods game in a sort of way, right? So they just stood up. Now the people behind them can't see. You can probably see slightly better, right? Maybe when you're sitting down, you couldn't see my shoes or something, right? But now you can. But everybody else is kind of not able to see. Eventually, if you stay like this, the people behind you will stand up. Everybody will wind up standing up, right, if it's the front row. And then we'll realize something's kind of funny about these two situations. The first is that when everybody's standing up, your view is now the same. Everybody's view didn't improve. Like, it briefly improves if you're the only one standing, but when everybody's standing, your view is all the same as if everyone is sitting. You can sit. Thank you for the thank you for volunteering there. But the point is that this is what an equilibrium feels like, right? So we have a situation where everybody's view is the same, but then if somebody stands up, it starts a process where everybody's view is the same again, right? But now this new part is stickier, because if somebody in the middle, for all standing, sits back down, it does not start a wave where people start sitting, right? That person just sits all alone, right? Whereas somebody standing up did start that wave. That's what an equilibrium feels like. An equilibrium is something where once you're in it, one person making a decision to get out of it doesn't make a difference. Sitting, in some sense, is not the equilibrium, right? Or if you want to go really deep, it's an equilibrium because people will tap you on the shoulder and say, please sit down, if they don't want you to stand, right? But that's the feel of an equilibrium, and that's kind of like, that's what's important about the concepts we're going to be using, is the kind of feel of it. What's sticky, what's not, and a public goods game in particular is differentiated by having the thing we'd all like to do be the thing that's not sticky, the thing that's really hard to maintain. And I want to point out that this way of thinking has been a treasure map historically through Web3 and public goods in particular. If you read this old paper from like Phil Diane and Amin Gunsirer, they, in so many words, talk about the Bancor protocol, an early DeFi project, and describe exactly how you could invent MEV, right? Similarly, if you read the early proof of stake stuff, they use game theoretic concepts at coordination games explicitly. This is just a Vlad Zamfir post. And they also, moreover, use behavioral game theory, which is, you can find early posts from Vitalik talking about altruism prime and concepts that go a little beyond the kind of like rational actor model. So now I've introduced a new piece of jargon. I need to explain it. I said behavioral. Behavioral is, it's a way of talking about non-rational, non-self-interested behavior among agents. The kind that we're all, of course, naturally used to, but we often find is a little difficult to talk about in models, right? It's mainstream game theory now. When I first got to grad school, I was like a behavioral economist, and people were like, you don't really even need to call yourself a behavioral economist now. We're all kind of behavioral economists to some extent. But I mention this because nobody really likes the word behavioral. We don't know what to replace it with. it just means kind of like non-rational, not perfectly self-interested. And you hear it all the time. When people say you dislike losses more than you like gains, if you read something about noise traders in AMMs, if you read about legitimacy, if you think about the sort of warm glow altruism effect that we think comes when people donate to public goods or donate to charities, all these things are fundamentally behavioral, right? They're people valuing the activities of others in a non-self-interested way, or there's, various different ways to do it, but fairness includes it. But the biggest important thing is coordination. So, it's all coordination is a phrase we hear plenty of times, and that itself implies behavioral game theory. So, I'm going to skip over the more like technical, nerdy quotes here, even though this is supposed to have a distracting Star Wars meme to make you feel like it's okay. And we'll just go right to the question of how we coordinate. So there's another conference later called Schilling Point. I assume many of you will probably be at it. Schilling Point, of course, is named after this guy, Thomas Schelling, who was one of the original people to ask this question. Game theory doesn't actually tell you which equilibrium to prefer, right? We have these two things in a coordination game, two sticky situations. How do we get from one to the other? Which one do we pick? That question is ultimately first answered by Schelling. And one of his answers is, well, look, one of them's focal. And so the Eiffel Tower picture comes from this famous story. He says, you're lost in Paris, you need to meet your friend, you have no other way to contact them, where do you meet them? And if you ask people on a poll, they guess the Eiffel Tower, right? And so it turns out to be a sort of focal point where you can coordinate on a meeting. Now that's pretty useful and pretty helpful, right? But it's not super descriptive. What we're really talking about is we're talking about introspection. You introspect and you say, here's the first thing I think of when I think of Paris. Apologies that it's the Eiffel Tower, maybe. But, and then you just sort of assume somebody else is going to be thinking about it too. And so similarly, when you play a pure like abstract coordination game in the lab, which this is what it looks like, by the way, you'll find that there's also something very focal on the thing that pays people the most money. So in this game, that like equilibrium, the one with all the arrows, 5-5, that's the sticky situation that gives me and the other person I'm playing with 5. Whereas there's another one down there, 3-3, that I'm not pointing to, that gives me and the other person $3. Preferring $5 to $3 is introspectively obvious, right? And so it becomes focal. So in the lab, that makes a lot of sense. But real life, it's not always as clean as the most money, right? Real life is filled with all these cultural signifiers and salient information and things that allow us to coordinate, but not always on the perfect thing. So going back now from the lab to that Eiffel Tower example, the Eiffel Tower is not that close. It's not that easy to get to. So in some ways, it's not the optimal solution, right? The optimal place to coordinate from a person, or with a person you're lost. Okay, so you're lost, and the other person, they're somewhere, right? The straight line in between you halfway is probably where you want to coordinate. Odds are that's not the Eiffel Tower. The problem is you just don't know where that is, right? So you coordinate suboptimally, but you do so because of this cultural information. This information about how, this is the famous symbol of Paris for a lot of people, right? That's what drives this, what's called an introspective equilibrium. And we can think of culture as doing this coordinating. So this is all very big and high level, but to bring it down a little bit, I'll talk about Zuzalu, which I think, several of you looking out in the audience were at. Yeah, what's up, man? As an example of kind of micro level culture or on the ground culture as a way of engineering or thinking around coordination as a problem, right? And I mean, part of what we're doing here is that as well. I just wanted an excuse to highlight this is old PhD work I did when I wasn't allowed to do crypto work. So I was excited to put it on a slide. Anyway, a treasure map to Zuzalu, basically. I'm talking about Web3 as a treasure map. We gave you a couple of examples. Now I'd like to show one that sort of predicts Zuzalu. Zuzalu was this pop-up city in Montenegro a couple of months ago, where a lot of people from Ethereum, but also synthetic biology and longevity and various different interests kind of came together. And a lot of interesting, exciting, varied things happened. And you can think of it as solving this interesting coordination problem. And to do that, I need to talk to you more specifically about something called an introspective equilibrium, which I gotta admit actually is gonna be a little less cool than it sounds. Sounds kind of like meditative and new agey, and it's not quite that, but maybe it's at least a little in that direction. So the thing to notice, this is going to be the one like mathy part, but real simple arithmetic, is that when you have this coordination game, the 5-5-3-3 game, you can think about failing this in two ways, right? You can pick the worst equilibrium, the one that's 3-3, and you lose, let's say, $2 or 2 tokens or whatever it is. Or you can just pick two different things, right? Alice moves down while Bob moves up, you both get 0. So you can fail by miscoordinating, where you pick the opposite thing, or you can fail by coordinating on the thing that pays you less. Oh. I don't know how that happened, but got it. Gives you more time with the math, which you all love, so over the best. Okay, so hopefully that makes sense. And you can think about the difference between these two things as the value of a game. I don't know if you've ever heard anybody try to talk about a coordination cost. It's very hard to formalize what a coordination cost is. This is kind of doing it. It's actually pretty new game theory, but pretty cool and pretty applicable. So here's what I just said, actually. And you can think of it in terms of culture, which is, this is not my theory, this is Katz and Sandroni's theory. Basically, you can think of a homogeneous culture, right? Ethno-linguistic homogeneity, and like a country where everybody speaks the same language, as preventing miscoordination, but causing sometimes suboptimal coordination. Everybody knows what to expect, and so they're all able to go to the Eiffel Tower, right? But even if the Eiffel Tower is really, really, really far away, they have a hard time finding a new equilibrium, even a better equilibrium. And similarly, you can think of the kind of okay not to always match, like a pluralist culture, a culture where there are different perspectives. It's maybe a less strong culture in certain ways in terms of being able to always coordinate on the same thing. But when you need to get to the better thing, you might be able to do it. So I did say that was going to be all the math. There's a little more, but basically the value of the game winds up being the difference between how much it costs to do the wrong thing versus how much it costs to do the sort of suboptimal thing, right? To miscoordinate with a person versus coordinating with them on the less good thing. And you can think of Zuzulu as being a sort of like pluralism play. So it'd be really cool to get together and talk about retro PGF, to talk about longevity, to talk about synthetic biology, but normally when you hang out with your crypto people, you just talk about crypto prices, right? So it's really easy to coordinate on crypto prices, but you can jumble some things around and you can find your way to a new, maybe better equilibrium at the cost of sometimes you want to talk crypto prices and the synthetic biology person you're talking to has no interest, right? So that's a miscoordination. And if X is low enough, then that's good, right? And it's worthwhile and it can kind of move you to the next better Pareto optimal equilibrium. So here's how this would look in this theory, the introspective equilibrium theory. It enables more optimal coordination, it increases the risk of miscoordination, and then what do you do when you're trying to do this in Zuzulu? What you want to do is you want to soften the miscoordination risk. So if you're having a conversation where you want to talk, number go up and the person wants to talk synthetic biology, yeah, normally it'd be 0-0, but look, you're at least in a beautiful place. Or, at least there's a cool event going on later or whatever, right? So the miscoordination risk is sort of softened. And you can think about the strategy of it. Again, this is my own little tiny keyhole view into this. I had nothing to do with the organization of this, really. It was an amazing group of people like Janine, who might be here, and so on. But like this is the micro game theory perspective. But it makes sense of some of what went on, which is kind of a neat thing. Explain some of the timing. It was the middle of a bear market, so maybe people were super not excited about crypto prices. And also explains maybe why it had to be curated, right? If you just invited a totally random swath of people, it might have been harder, even if they were interested, because maybe you can't speak the same language. So my own little minor contribution to this, I mentioned just because it was kind of in the same direction theoretically. It was a muse dinner where you matched with strangers, and then you had a conversation menu, and it kind of does the same thing. So stranger matching increases miscoordination because you can wind up talking to somebody you don't want to talk to, but you might find a new positive equilibrium, somebody you really like talking to and they become a friend, right? And then to maybe soften that sort of off equilibrium risk, you're talking to somebody you have no idea what to say, we provide a conversation menu that lets people at least struggle towards something. Just kind of a micro level version there. And then, how am I doing on time, by the way? Oh, good, cool. All right, so that would be a sort of like treasure map to the recent past. This will be maybe a treasure map to the future, we'll see. This is something called the SCAM mechanism. SCAM stands for subgame credible altruism. And to introduce it, I need to tell you about like one of the coolest, most robust findings in all of behavioral game theory. This has been repeated hundreds of times. I personally have seen this result dozens of times in person, and it's been played all around the world. And it takes place over something, might sound familiar, called a public goods game. The public goods game has the flavor of that public goods game we just played, the stand-up. And what I need to tell you is that the temptation to get a better view by standing up, that's called the temptation to defect in the public goods literature. And that's what causes people to sort of free ride. Like all those words they mean effectively the same thing. And what you see when you play this game is that you have a lot of people who do not stand up, even though they would sort of be better off. And that stand up is meant in monetary terms. I could run you through it. It would honestly be a little complicated, but it has the same feel. So you can think of like one person out of this group of 10 stands up. And then what you see, that number going down, is everybody else sort of standing up and doing the suboptimal thing because they just can't see. They're losing money is what it winds up being, right? And you see this really consistently. You also, I should say, see some really beautiful optimism, which is to say, again, sticking to the left side, if you repeat this over and over again, people will always try to start by sitting. Like, even if they know that the game will devolve into everybody standing, they'll always start optimistic. It's really kind of a cool finding that you see over and over again, but it does always devolve. But there's one thing we found that can really consistently prevent it, and that is something called altruistic sanctioning. And altruistic sanctioning is, you give somebody the ability to penalize people who are free riding, and they have to penalize at cost. So I have some money, the person who's standing up, I have to pay a little money, but then they lose some money for standing up, is effectively how it works. And what that does is it gets cooperation to be sustainable right off the bat. So you can see on the graph on the right that the level of cooperation, which you should see as the sort of like vertical axis, is a little bit lower in the first round. Then the punishment starts, the sanctioning starts, and then cooperation is sustained the whole rest of the time. And if you're a game theory nerd, you might find it interesting that even in the very last round, it's pretty well sustained, which you would not predict in theory, but cooperation can be a little like inertial like that. So it is this cool, widely replicated finding. It's something that we don't actually see in crypto, even though a lot of the ways it's implemented is kind of friendly to the tools we have in crypto. It's not super easy to do, but it can be done. And if we're interested and excited about this way of sort of funding public goods, or I don't know if it's funding public goods so much as like sustaining the funding of public goods, right? So maybe thinking in terms of AntiCivil, I originally presented this in terms of MEV, the things that wind up being retro public bads, we might say. This is something that can really do a good job at that. So again, more like game theory nerd stuff, does not require repeated game assumptions, reputation, etc. And it's credible in the one shot. So this is the thing that again sounds technical, but what I mean by credible in the one shot is that it's psychologically driven. When you see somebody doing something wrong in this game, you are paying to punish them. There's a cost to yourself. And so the way we model that is it's a psychological benefit you get for justice, right? For the benefit of yourself, maybe, for the benefit of the group, whatever, but it is actually a financial cost to yourself. So that's what makes it credible. It's credible because it's psychologically beneficial to you. And for that reason, you can do it in one game. It doesn't mean you're gonna do it so everybody believes you're gonna punish them in the future, or that person gets the message or whatever. It's just, even if you don't know who they are, even if they don't know who you are, you don't want to see them rewarded for screwing over the group. So the example would be Sybil, right? Obviously we know that one of the ways you can sort of attack quadratic funding is you can try to Sybil the matching pool. Well, I think people are rightly emotionally frustrated by Sybiling the matching pool, right? The sense that you're basically stealing from these very cool projects that need matching funding and this very cool mechanism and so on, right? If you don't want to see somebody rewarded for Sybiling, and you would actually find it beneficial to yourself to know that, hey, they're not out there profiting off of this stolen money, then that's what this mechanism would allow you to do. I can talk in more detail about the implementation, but that's kind of the TLDR, is you provide some sort of stake, it becomes a subjective slashing mechanism where the person has to pay to slash, and that removes the person's stake. It's pretty generalizable, but we've written up on the Gitcoin forums how you do it for Sybil, and I've written up elsewhere how you would do it for MEV. We'll skip this stuff. It works because of utilities. It's basically what I just said about you find it psychologically beneficial to do this stuff. It's basically, you don't like to see injustice is more or less how it works. If anybody's interested, I'm happy to go through it, but no need. And then again, this is how it works in terms of turning a public goods game into a coordination game. The way it works is the defect temptation. I said the temptation to defect is the better view you get when you stand up. That's that 15 number on the left. And if you start sanctioning people who stand up, then that 15 number goes down to the 1 number on the right, or however much you sanction. So when you move 15 below 10, technically, it stops being a public goods game. It becomes a coordination game. And when I say it becomes a coordination game, it becomes a game where the best thing you can do for everybody is sticky. Like, it's sustainable. It's something you can keep going, which is ultimately, I think, what we all want. Turning a public goods game into a coordination game is the only way to solve it, in theory. And so this is one sort of interesting avenue to do it. And I think behavioral game theory is kind of an unexplored but promising way to do it. So thank you, everybody.